at 127, and this is the last lecture we're going to have, and I'm not going to do any more stuff in the book. I'm going to do more machine learning demos. I've added a bunch more machine learning projects since I demonstrated the first 3 projects of several weeks ago here, and I think it's very interesting. I finally got one working today that has a good evasion attack that shows the whole point of evasion attacks, which are a serious problem in machine learning models. So all I'm going to do is demonstrate those things and then answer questions that may come up from students. Next class, I'll have no new material. I'll just answer a question, and that's it. Then comes the final exam. This course is essentially over. So the machine learning demos, the machine learning projects, you'll find them on my home page. I did not put them on the 127 projects page because the semester is nearly over. I'm putting them here, where I'm accumulating them to use them in workshops over the summer. And this has an automated scoreboard you can use. You can also send them into Canvas to collect credit. So the first 3 we talked about before. So I'm going to make videos demonstrating the others. So let me start with 103 here. All right, so I'll open 103 and talk about it. And so we're using Google Colab as before, and there's commands to download the images and such. So what I'm going to do is move the instructions to my other screen and just put the Google Colab on the screen that is being recorded and projected so you can see this stuff go by. So I make a new notebook, so I got a brand new environment with nothing but the default stuff in it. And now I have to download some blurry images. So in Google Colab, an exclamation point lets you execute shell commands. So I download a file named blur.zip from my server and unzip it. So there it goes. And now I have to import those images into Python. So I got a bunch of code that does that. All right. There it comes, blur.zip coming down. And unzipping, turning into many images. And you see they're all named after different cameras. They actually took a bunch of images with all different cameras and then blurred them. That's why there's so many images. All right, now I'm going to add another block of code. This block of code imports the images and prepares them for use. And it prints some examples of the images. Try closing these other tabs. I guess it doesn't matter. All right. So it's importing and I think converting the images. It's got 2 batches of 350 images. I went and picked part of the images from the database. All right, and now it's going to plot a couple. So there we are. Here's a sharp image and here's a blurry image. That's what you got. You got 350 examples of sharp and blurry images. All right. Now we're going to split the data set into training and testing portions. So I'll add another block of code. All right, this code takes the data and it sees the random number generator with a fixed number of 21. This is commonly done, so it's not really random. It's starting from here, so each student that does it will get exactly the same series of random numbers. And then it takes 20% of it to be the test size, and the rest will be the training size, and it prints out the shape of these arrays, which will tell you how many elements there are. Just a convenient way to see. So here's what the shape it is, 128 by 128 by 3. So each image is 128 pixels by 128 pixels by 3 colors. So these are full color images. All right. And now we have to encode the images with some of these AI-specific libraries. All right. This is going to encode them into the right format we need. So there it is encoding, and now you can see the model. So it encodes it with a layer of neurons, 1,700 parameters, then another layer and another layer, and then a flattening layer and a vector. So it goes through several layers, and so the number of parameters is now up to 16 million. So it builds an image processing model. We have 17 million parameters so far. And after you encode it, you then have to decode it. And that's very similar. Another block of code. And again, this one, I printed the summary of the model so you can see it. This again has a hidden layer with 17 million parameters, and then more in here. So the total parameters in this one is also 17 million. And now we can train the model. So this code will train it, and I may not be able to wait for it. I think this one's going to take 5 minutes to go through 5 epochs of training. It's a pretty big model. It's the biggest model of any of my projects, 34 million parameters. And so it takes a while to run. And I think rather than waiting for it, I'll just go back to it to describe the results, because the results are not that interesting unless you spend more time. So when you're done, it'll take 5 minutes to train, and you'll get a flag. And then if you want to see the results, here's the results after 5 epochs. This blurry image, this is the sharp image, and this is the supposedly deblurred image. So as you can see, they're terrible. After 5 epochs of training, it is not enough. It's not powerful enough to do any significant deblurring at all. All it does is ruin images. And so you have to train it for 100 epochs, which will take more than an hour. And if you do that, then it will actually do a good job. Here's some examples of that. A blurry image, here's the sharp image, and here's the deblurred image, which, as you can see, is sort of in between the two. It has accomplished some degree of deblurring. So there's various flags to find with various alterations of it here. But that's all I wanted to demonstrate about that one. I'm going to stop this recording.